Applications of slope-intercept form. At the end of this lesson, you should be able to answer how can an equation model a real-life situation, and then also be able to create equations that model real-life situations. Specifically, remember we're looking at linear equations. We're going to start by looking at a very simple question that sometimes trips kids up. It says, write the equation of a horizontal and a vertical line through the point 3, -8. What might be helpful is for you to sketch a picture. So I drew the picture of the vertical and horizontal line that passed through that ordered pair. And what I think about is, let's talk about the horizontal one first. This is y equals the rise and the run. Well, the rise is 0. So that gives it a whole slope of 0, 0x, and it's fixed at a y-intercept of -8. So that means that this one's going to be y equals -8. Another way of thinking of that is your y value is fixed at a constant -8. In the red line here, the y value changes, but the x value remains the same for every ordered pair. It's always fixed at the point 3. Another way of remembering that is an acrostic called Hoi Vux. Some kids memorize this, and H stands for horizontal, has a 0 slope, and it's in the form of y equals. Vux stands for vertical lines, have undefined slope, and they're in the form of x equals. So if you're asked for a horizontal line, you think, oh, hoi, well that ends in a y, so it's y equals, and you look at the y value, it's -8. Vertical, Vux, is in the form of x equals, so it would be x equals 3. Example 2 in your notes really gets into real-life examples. It says the table shows the balance of Jared's savings account each month. Explain why this situation can be modeled by a linear equation. And to get a sense of what all linear equations have in common, I graphed these points so you can see that it is indeed linear and makes a line. Well, what do lines have? Well, if you think about it, any part of the line I circle, it's going to have the same slope. The line does not get steeper at any point, which is what makes it linear. So if the slope is the same, another way of describing that would be to say that there is a constant rate of change, which is why a linear model will work. Now let's actually find the linear equation. So we're going to need 2 points, or another way of looking at this is, you may have noticed this initially when we said there's a constant rate of change. If you look at how much the y values are going up, it's going up $125 each month because the x's are only increasing by 1. So you can do it that way, or you can actually select 2 ordered pairs to find the slope. So I selected the first 2, subtracted my y's and my x's to get a slope of 125. I also need my y-intercept, so I begin with slope-intercept form and substitute. Plugged in 750 for the y, 1 for the x, and I use my slope I just found of 125. Solve this equation, I get 625 is the y-intercept. Now the equation normally has a y and an x, but the directions tell us to use b and m, which can be a little confusing because you're accustomed to m being slope and b being the y-intercept. But here b is your balance, so it would be balance equals 125m plus 625. Now what do these actually mean in the context of the problem? Again, I'm showing you the graph to kind of help you think through it. The 125, remember it's change in y over the change in x, so it's changing in dollars because that's your y, change in dollars per month over your x. So I would say that the 125 would be that Jared deposits $125 per month. Now, the y-intercept is always like your initial value or your starting point. Well, at 0 months, that would be how much money he has. Therefore, that would be like his initial deposit. You could describe it that way, or that his starting balance was $625. Okay, similarly, example 3 says a cable company charges a monthly fee of $60 for service. To use the service, it is required that you must first buy equipment that costs $250. You're supposed to identify the rate of change. Well, when I look for a rate of change, I always look for something per something. This one is not as obvious, but you're told a monthly fee of $60. So you could also say this would be $60 per month, and that will help you state your rate of change. So I'm saying that my rate of change is $60 per month, and the starting point, well, it cost you $250 just to sign up. Once you know these two things, writing the function is very simple. Write C as a function of the number of months of service. So I'm going to say that C of M is equal to 60M plus 250. Remember that C of M is another way of saying like C equals. It's just written in function notation. We're then supposed to find the total cost after 1 year of cable service. Well, remember you just wrote your function in terms of months. M was the months. So I write down my equation, and this time I'm plugging in 12. I have to find C of 12. So I do 60 times 12, which is 720, and then I have to combine my like terms. So C of 12 is equal to $970. So it would be $970 for 1 year of cable service. Example 4 says, a city is paving a new highway, and the same length of highway is paved each week. After 4 weeks, there are 8 miles of highway remaining to be paved. After 10 weeks, there are 5 miles of highway remaining to be paved. Again, we're asked why this situation can be modeled by a linear equation. And it has to do with that constant rate of change. Can you see a constant rate of change? And it tells me that they're paving the same length of highway each week. So there is a constant rate of change because they pave the same amount. Now we're supposed to write an equation that gives the distance in miles remaining to be paved, called D, as a function of the number of weeks since the project began. Now, whenever you're asked to write a linear equation, you are in some way given information that will help you find the slope and the y-intercept. So sometimes you're given the slope, sometimes you're given 2 points and you have to calculate the slope. I see 2 points here. I labeled them as in 4 weeks there'll be 8 miles left, and in 10 weeks there'll be 5 miles left. So since I have that, I can find the slope by doing y2 minus y1. So I do 5 minus 8 over 10 minus 4. Results in would be negative 3 over 6, which reduces to negative 1/2. So I also need my y-intercept. So I start with y equals mx plus b, and I plug in one ordered pair. Doesn't matter which. I selected the first. Do the math, and I get 8 equals negative 2 plus b, so I'll add 2 to both sides, and I get 10 equals b. Therefore, the equation of my line has to be written again using the given letters, so I say D equals negative 1/2 W plus 10. Finally, it says use your equation from part B to determine how many weeks it will take for the entire highway to be paved. So I take my equation, and if I want the entire highway to be paved, the key to this is what's the distance that's remaining? And that would mean that there's nothing left to be done, so I substitute 0 for D. Now it's very simple. I'm going to subtract 10 from both sides, which gives me negative 10 equals negative 1/2 W. Then I multiply both sides by negative 2, the reciprocal, tells me 20 equals W. Therefore, it will take 20 weeks to pave the entire highway. Remember, for all linear equations, you are in some way given enough information to find your slope and your y-intercept. Some story problems get very confusing, but sift through the information and try to write either the ordered pairs that you're given or the slope.